Hi and hello everyone. What's up today? I'm so excited to be here with you on today's episode of Question for the Day. And on today's episode, we're dealing with a question that has to do with the empirical and the molecular formula. By the way, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. All right, so we have a question on the screen right now that starts off by saying a compound contains 40% carbon, 6.71% hydrogen, and 53.29% oxygen by mass. If the relative molecular mass of the compound is 180, determine first of all the empirical formula of the compound and then the molecular formula of the compound. So before we go into solving this question, here are the steps to getting the empirical formula and the molecular formula of a compound. Step number 1 says to assume 100 grams of the compound. Step number 2 says convert mass to moles. How do you do that? You simply say number of moles is equal to mass divided by molar mass. And since we're converting mass to number of moles, we simply use this as the subject of the formula. Next step says divide all through by the smallest number of moles and then find the empirical formula mass, and then you find the molecular formula. The formula for the molecular formula says molecular formula is equal to N multiplied by the empirical formula. We're going to apply all these steps one after the other. So let's get into the solving of this question. So to begin off, we need to assume 100 grams of this compound. So for the first one, we have carbon. Carbon is 40%. We have hydrogen, 6.71%. And we have oxygen, which is 53.29%. So the first rule says assume 100 grams of this compound. So we take away these percentages and turn them into grams. So we have for carbon 40 grams, we have for hydrogen 6.71 grams, and we have for oxygen 53.29 grams. Next step says to convert them into number of moles. How do you do that? You divide by the molar mass. So number of moles is equal to mass divided by molar mass. For carbon, we have 40 divided by the molar mass of carbon is equal to 12. The relative atomic mass or molar mass of carbon is 12. So we have 40 divided by 12, which gives us 3.333 moles. For hydrogen, the number of moles is equal to the mass, which is 6.71 divided by the molar mass. The molar mass of hydrogen is 1. So we have hydrogen is equal to 6.71 moles, because anything divided by 1 basically remains the same. And then for oxygen, we have the mass 53.29 divided by the molecular mass of oxygen, which is 16. So we have 53.29 divided by 16. We have 3.33 moles. So the next step says to divide all through using the smallest number of moles that you have. So we have for carbon to be 3.333, for hydrogen to be 6.71, and for oxygen to be 3.33. The smallest among them is this guy, 3.33. So we're going to divide all through by 3.33. Divide all through by 3.33. When we do that, the first one is going to be equal to approximately equal to 1. The second one is going to be equal to 6.71 divided by 3.33 is also going to be approximately equal to 2, and the third one will be equal to 1. So we have 1, 2, and 1. So the next thing to do is to assign them to each element. So we have 1 for carbon, 2 for hydrogen, and 1 for oxygen. So altogether, the empirical formula of this compound becomes CH2O. The this is the empirical formula of the compound. So now that we have done that, let's go ahead to calculate the molecular formula. How do we do that? Molecular formula M is equal to N multiplied by the empirical formula. Now, we are told that the relative molecular mass of the compound is 180, and the molecular formula of a compound will always correspond to the molecular mass. So we can substitute this to be 180. This will be equal to N multiplied by the empirical formula is CH2O. So let's calculate the mass of this guy. We have C is equal to 12. That's the atomic mass of carbon. H is equal to 1 and O is equal to 16. So altogether we have 12 plus 1 times 2 because we have 2 atoms of hydrogen plus 16. So we have 14 plus 16. 14 plus 16 will give us 30. So we have 180, which is the molecular mass, equal to N multiplied by 30. N will now be, we have 180 is equal to 30 N. N will now be equal to 180 divided by 30. This cancels this. This cancels this. 3 into 3, 1. 3 into 18 gives us 6. N will be equal to 6. So now we can use this information to find our molecular formula. How do we do that? Remember, molecular formula M is equal to N multiplied by the empirical formula. We have our empirical formula to be this. So our molecular formula will be equal to N6 times CH2O. So if we open this bracket, the molecular formula will be equal to C6H12 because 6 times 2 is 12 and then O6. So this is the molecular formula of the compound, and the compound's name is glucose because glucose is the only compound that has this molecular formula. I'm sure you enjoyed every bit of what we did in today's video. So by way of going back over what we did to get the molecular formula of this compound, we first of all assumed 100 gram of the compound. We converted it to moles. We divided through by the smallest number. We found the empirical formula mass, and then we found the molecular formula using the formula N times empirical formula. I'm sure you enjoyed it. Please do well to like, share, subscribe, and I will surely see you in the next video.